Okay, as I said in the previous video, we have this process of applying iterative by parts integration iteratively. Let's use this to find an expression for integration of sine to the power nx, where n is an integer. This method is called reduction. So, which means we are going to express this integral in terms of integrals of lower powers of sine. Okay. So I rewrite sine to the nx as sine to the n minus 1x times sine x, and I choose u to be sine to the n minus 1x. I get du. I choose dv to be sine x, and v is negative cosine x. Integrating by parts gives me this particular expression. Now a trig identity we know is sine squared plus cosine squared is 1. So I can replace this cosine squared here by 1 minus sine squared, and then I do the math, and I end up with this expression right here. So you don't have to remember this expression. All you have to remember or know or understand is why is this helpful. It's because what we are doing here is we are reducing an integral of sine to the power n to an integral of sine to the n minus 2. So, and then we can find for n minus 2 would be n minus 4, which means it has to eventually halt at some place. For example, for sine cubed, it halts at integral of sine x, which you know is cosine x, so you're able to solve. It's a bonus problem. Try to find the reduction formula for cosine to the power nx. It works exactly the same. You have to use the same identity, meaning sine squared plus cosine squared equals 1. Now, what if it's a definite integral and you are applying by parts? Well, nothing changes much. You just apply these limits, a and b, to both. For example, tan inverse of x, which is arc tan x. So I take u as tan inverse x and dv as 1. So du is 1 over 1 plus x squared, and v is x. So I get x tan inverse x 0 to 1 minus x over 1 plus x squared 0 to 1. I just plug in 1 and I get 1 times tan inverse 1 minus 0 minus the integration. Now the integration of the second part can be done by substitution. That is, you substitute all of the denominator, that is 1 plus x squared, to be t. Then you get dt is 2x dx. Just making sure you change the limits. As x goes to 0, t goes to 1, and as x goes to 1, t goes to 2. So it's a 1 to 2 dt over 2t, which gives you half ln 2. And the final answer becomes pi over 4 minus 1 half ln 2. Okay. The next series will be about trigonometric integrals.